Hello everyone. This is the summary of our work on exploiting the layered intrinsic dimensionality of deep models for practical adversarial training. So the motivation of our work is trying to understand the robustness and generalization relationship in the context of adversarial training. For instance, in vision models, adversarial training leads to a significant improvement in robustness, but it causes a substantial drop in generalization. On the other hand, in NLP models, like especially encoder-based language models, adversarial training either maintains or improves generalization. So what is the reason for this difference in observation? So based on the literature, we observed that when we have off-manifold adversarial examples, they improve robustness. And when we have on-manifold adversarial examples, they improve generalization. So when we relate this observation with the behavior of vision and encoder-based language models, we may say that vision models may have higher off-manifold adversarial examples compared to encoder-based language models because it has better robustness. So we extend this hypothesis and we think about it like in the conventional adversarial training, which happens at the first layer. So adversarial examples tend to be more on-manifold for encoder-based language models, and they tend to be more off-manifold for vision-based language models. And if this is true, then this will explain the results of generalization and robustness trends. In other words, higher proportions of on-manifold adversarial examples lead to better generalization. So we observed the trend on encoder-based language models and also on the vision models. So here we plot the off-manifold trend in both of these models, and we can see that off-manifold adversarial examples tend to, in encoder-based language models, they're increasing across layers, while the pattern is substantially different for vision models. So in the next step, we thought, can we relate this somehow with the intrinsic dimensionality of a layer? And there our hypothesis is if a layer has a smaller intrinsic dimensionality, then it is likely to have more off-manifold adversarial examples. So the second figure plots the intrinsic dimensionality, and we can see that the trend is strongly correlated with intrinsic dimensionality, where higher intrinsic dimensionality results in low off-manifold examples. So this proves our hypothesis, which is lower intrinsic dimension results in high off-manifold adversarial examples. So in other words, then we can think of how can we increase the robustness of an adversarial training? We can generate adversarial examples in the layer with the lowest intrinsic dimensionality, which is the last layer in Roberta. So we don't have to go to the conventional adversarial training as a first layer, but in Roberta and other encoder-based language models where we have this trend, we can go to the last layer. And this is where we propose our method, which is scalable manifold aware adversarial training. So first we find the layer with the lowest intrinsic dimensionality, and then we perform adversarial training to that point only. So instead of having the full backward pass to the initial layer, we only do the training to the layer with the smallest intrinsic dimensionality, and this improves scalability, robustness, and generalization. We performed an extensive evaluation on many different tasks, and we achieved state-of-the-art runtime and robustness results on all of those tasks, especially when we looked into the encoder-based language models. So if you are interested to know more about it, check out our paper. Thank you.